this first slide here is illustrating the way the FHIR specification works currently before doing before using the technique that Harold is going to demonstrate that we want to switch to. So at the moment, on the lower left here is the FHIR RDF specification. That person thinking there is a programmer digesting the specification and figuring out how to code a custom RDF converter or generator to go from the FHIR internal resource object that is represented, actually physically this is actually represented as a Java object in the probably both in the Happy server and also in the FHIR specification build process. But anyway, then it's a manual process currently to write that RDF converter that knows how to produce and generate FHIR RDF. So what we want to do now is to enable a more automated means of doing this, such that the FHIR build process here on the lower left will produce a context library for JSON-LD. Now, I guess I should flip back for just a moment to remind you what a JSON-LD context is.
We'll be talking about that a bunch more, David.
Okay, all right, fine.
Yeah.
So basically, the context is either a separate bit of JSON or a separate file in JSON. It can be either in the same file or not. But anyway, it's basically provides a mapping that shows how to go from regular JSON into basically into RDF. So it tells you how to map the property names of JSON into full URIs on the right. So that's basically the role of the context.
Yeah.
So the idea.
Yep. I'll be touching on that a lot more. So.
Okay, good. Thanks. So the basic idea then is to enable a process in which the FHIR build process, this is the process that builds the FHIR specification, the entire FHIR specification, so that it would generate those at context files that could then be plugged into a standard JSON library, JSON-LD library, excuse me, such that FHIR JSON, which is already being produced for FHIR, can then be converted into FHIR RDF in a more automated means. So this is the overall vision that we're going after in the use of JSON-LD, and in particular with JSON-LD 1.1. And just to refresh you all, that this is an option, this is a possibility that we actually investigated some years back before we did the first version of FHIR. But at that point, JSON-LD was in its first version, and it didn't have the features that we needed to support what we wanted to do.
And I'll be touching on that also.
Version,
yeah.
Okay, wonderful. But the new version of JSON-LD 1.1 now had some additional features that now enable a lot more work to be done. So this is the overall context that I wanted to give you.
Can I ask a very quick clarifying question?
Yeah, sure.
So on this diagram, I see that the arrow goes between FHIR JSON and JSON-LD, as opposed to from the FHIR resource object to JSON-LD. And so am I correctly interpreting that you have to go through JSON in order to do the JSON-LD pieces of this?
Yes, that's correct. I think that's correct. Yeah.
Yeah, that's correct. And there is a couple things to note on this slide, which we'll touch on a bit more later. First off, there is an error on this slide in that FHIR RDF has an arrow pointing to it, but this is intended to be bidirectional. So,
oh yeah, that's a good point.
Okay, and the other thing that we haven't noted here, and it's something that we're counting on happening, and it's happening more slowly than what we expected, is that the thing labeled JSON-LD library are standard JSON-LD 1.1 processing libraries that we're we're counting on the JSON-LD community to get those libraries put together. There's a really good one out there for Java right now, and it looks like Python's coming around. When it comes to JavaScript, that is the definitive library that's used in the spec and what I'm going to show today. I'm not aware yet of a C# library for JSON-LD, but we still need that bit.
And I don't remember. Let me just take a look at the next slide to see if we mentioned the pre-processing. Okay,
and I'm gonna cover more of this.
Okay, you're gonna get into that.
Yeah.
Okay.
I just assume.
Okay, so let me just mention that this is the sort of idealization of just being able to use the context library in order to go from the FHIR JSON into the FHIR RDF and back again. But there is one little detail. It turns out that JSON-LD 1.1 doesn't give us quite everything that we need. So there is a little bit of pre-processing that we need to do as well, pre or post-processing.
Yeah, and I'll be
in order to make it all work out. Okay, so this is probably a good opportunity now for me to turn it over to you, Harold.
Two clarifying question.
Oh yeah, sure, absolutely.
Harold, will you be discussing the difference between a context library and the library?
And the library?
So because in the diagram there was like FHIR context library, FHIR JSON context library, and then the JSON-LD library.
Yeah, I think. Let's see, just a second. Let me get this screen up.
And
Okay,
also,
are folks?
Yeah, I can see.
Okay, just wanted to make sure the screen share was
And
up.
the second question is that is the JSON-LD part is like, I'm just naively saying this is XSLT, like transformation language from one XML to another.
No.
Like
Tell you what, let me dive. I think it'll be clearer if I go through this a
Okay.
little bit.
Sure.
So, okay.
Just a second. One other thing. David, can you mute? I think we're getting a little bit of echo on Harold.
Okay, yeah.
There we go. All right. Yeah, that echo went away. So starting off with the state of the FHIR RDF spec today, one of the things that we've never gotten fixed, and we really just need to get a bug report in, is when we get here, when you go to the basic framework, you get XML, JSON, and RDF should be there. But the way to get there is to click through the JSON, and then here is the actual FHIR RDF spec. Another thing that's been on the list for some time is this dead link, which we do need to get fixed. This is the written specification with a whole series of examples and what have you. A wonderful job that David has done. And this specification, the first implementation of this specification, as far as how the various elements and what have you go through here, was done in the FHIR build process itself. So if you go to a FHIR resource today, we'll grab patient for no good reason. And if you go to the examples, you will notice that all of the examples are available in 3 different formats: XML, JSON, and Turtle. And this Turtle format, which is the Turtle representation of RDF, is generated by the build process. So every time they rerun the build process, all of these files get regenerated. So here's in fact, if I step back a second, if we look at this general person example in JSON, you get resource type, ID, text, active, true. And then if we go to the Turtle, this is the RDF representation of the same thing. The resource type becomes an RDF type. If I scroll down further, our active becomes a B node that has a FHIR value of true. I'm not going to go into a huge amount of why that's there today, but the way the spec's written today is that because all of these data types are extensible, instead of just saying active true XSD Boolean by having this B node, if somebody wanted to extend Boolean, the extensions would appear inside the B node. That's just part of the spec. So we have this generator that's written and run, and it's kept current so that every time the latest greatest FHIR build, which by the way, if you see, if you go out to build.fhir.org, this is essentially FHIR's continuous build. This specification is updated on a regular basis. And again, we can go down to something, pick an example, and see what it's like in Turtle.
And Harold, if one makes changes in the, if one is authorized to make changes, pull requests, etc., in the main FHIR GitHub, is build.fhir.org where those appear when it's active?
It was at one point in time. Build.fhir.org still builds all of the HTML you see here, or it's the repository itself for this one is HL7 FHIR. This repository right here is the source code. If you clone this and basically run the build, I think it's called build.sh. I thought there were, anyway, publish.sh or publish.bat or what have you, you get an exact image of what's here. And so if I make changes to that GitHub repository and push them, the continuous build process will reflect them out here eventually. The reason I qualify that is because they've sensibly separated some of the reusable libraries, for instance, for generating the turtle amongst other things, from the build process, and they're actually they appear in a different directory now. Let's see if I go to GitHub HL7. Okay, and let's see. I'm looking. I'm not seeing it right there. It's org.hl7.fhir, and maybe I'm trying to remember. Was that there or in Happy, folks? I can't. Let's see. It might be here actually. Yeah. Okay. So a lot of the core libraries have been moved to the Happy FHIR organization under org.hl7.fhir.core. So these libraries get rebuilt and then they get pulled into the build process. But and one of the reason, or amongst the reasons that this is here is the RDF, because when we published the RDF in the specification, we got 2 RDF implementations done. One was in the build process itself so that we could build all those examples. And the second was in a test server that Graham Grieve maintains, that he's delightfully kept current. But the problem we had was when it came to Happy or Simplifier or other FHIR servers, they were more than willing to incorporate the RDF specification if either A, somebody would write it for them, or B, we could demonstrate a strong community demand for the thing. And the problem we had is, in order to generate a community demand, we had to have this stuff available in servers so people could start kicking the tires and seeing how to use it. And that ended up being a big issue. The other issue we faced with this current implementation is that while this is the first draft of the spec, as we've started to use it in anger, we've discovered some of those decisions, like the ones we made on the B node, using the B node for Boolean, are suboptimal. So we want to actually start tweaking the spec. And if the spec is implemented in code libraries out there, it's going to take a long time for tweaks to propagate, if ever. We're worried that if we continue to tweak enough, we're going to actually convince folks that the RDF spec isn't mature enough yet for anybody that bothered to implement it. So that leads us to JSON-LD. And what I'm going to do is just let's see, JSON-LD. Okay, by the way, as far as a great way to publish a spec, I would, this has just got to be one of the most delightful jump off points for a specification. This JSON-LD.org has all the specs and documentation and examples, and it's actively maintained by the developers of the JSON 1.1 specification. And in fact, while we were working on the specification, changes appeared almost immediately here. One of the key places that's really fun is the JSON-LD playground. And this is the JavaScript, the definitive JavaScript implementation of JSON-LD 1.1. And so what I'm going to do is just, I've got one up here to look at. So, okay, just walk through a little bit about what JSON-LD is all about and why it works for us. Oops.
Carol, can you drop links into the chat as you're going to, so that I can get them in the either directly into the IRC or in the chat, so that I can get them.
Okay, well, this is just the playground thing here. I'd rather, if somebody else can drop them in, that would be nice, because
okay, maybe somebody else. Eric, could you do that?
Okay, so if we've got just a simple bit of JSON-LD here, let's say I've got what I'm looking for here is, all right, okay, I've got a name, Jim. Just going to put in okay, ID colon 1 2 3 4 5 and age 42. Okay, this is just the good old JSON that everybody's familiar with and uses. And the question or the task is, how do we reflect this in RDF? Well, the thing we need to do is, if we look at this, is we can say, well, name, ID, and age look suspiciously like predicates, and a Jim 1 2 3 4 5 and 42 looks suspiciously like RDF literals. So what JSON-LD's done is they've as with anything that gets bolted on after the fact, they've decided that an @ sign in front of a tag is meta information, and in particular JSON-LD uses @ sign context and a few others here. So what I'm doing is I'm adding a context inline, and I'm just going to build a simple map here. So I'm going to say, okay, I want name to match to friend of a friend name. The first thing I'm going to do, just as a shortcut, is I'm going to put in a query map here. So I'm going to say, okay, when I say friend of a friend, I mean this prefix. Okay, now I'm going to say that name maps to friend of a friend name. That's the predicate here. And if you look at this in RDF, now that I've said, okay, I know what to do with name, it maps to a friend of a friend predicate. I've now got a single triple out of this RDF that goes here. Similarly, if I want to do age, see what did I think? So I need to switch it back. There we go. I'm not actually sure whether schema.org has an age, but I just threw it in. So I said, okay, I'm going to add a new query prefix here. And now I'm going to map age to SDDO colon age. Okay, so now I've got two triples down here. By putting in this map, I've added two prefixes and two aliases. And by the way, some of you may note that there's an interesting question of, how do I know that SDO is a prefix rather than an alias? And they've kind of muddled that area. We're hoping that a revision to the JSON-LD spec allows you to change that. There is a way inside, but it's really difficult. Basically, if it looks like a URL and it meets all the requirements, it's a prefix. Otherwise, it's an alias. So I've put in two aliases here. Now,
just a second. Prefixes now can be isolated in their own, right? You can say @ prefixes in there, and they get more.
Yeah, there is a way at the moment. The problem is to isolate it. You have to put a nested structure in here where you say this at prefix true and its ID is this. What we're hoping at some point is to get a wrapper so we can say prefixes at prefixes and put them all in here. One of the things that some of the community has discovered is because we've said it has to look like a prefix, the OBO community has started this interesting pattern where they might do BFO underscore, which says that it's a little beyond the Curie spec or what have you, where the number or the code would go after that. You'll notice what happened below is that it doesn't look like a prefix because of that underscore, or it doesn't look like a URL prefix according to the Curie spec. So it's assumed that SDO is just an alias, which then means that this little SDO.age, we've just mapped it to SDO.age. It's you'll see what happened down here below, but that's kind of a side thing here. Okay, so what I've done is I've put in a couple of fields. Now you'll notice one is missing. One of the tricks we use or we often use is the rule in JSON-LD is if there isn't a map for it, you don't omit it as RDF. You can change that by specifying a default vocab, which is, this is the default prefix if it's not specified. And what folks have ended up doing, just because what we really want to do is know that that this isn't mapped, is they just put it in as something like this, so you can pull it out and you can say, ah, look at this, my ID field hasn't been mapped, and so I've got an unknown out here. But anyway, I generated 3 triples now, and you'll notice that the subject of all 3 of these triples is a B node, and that's one of the basic problems. Is in JSON-LD, you've got it's a tree structure, but there's no identifier. We don't have something of the form of X colon. That's just not valid JSON-LD because X would be considered to be the subject of what's in here. So our first challenge is, how do we identify the subject? And so what you can do is you can say, all right, the subject of this is in the ID field. Oops, yeah. I want to go the other way though. I want to say ID maps to, this is a keyword at ID in JSON-LD. Okay, so now what it said is, instead of the ID being part of the triples here, that's going to be the subject of these things here. You can find the subject here. Now, the default subject uses these interesting document rules that Eric's familiar with. Suffice it that it's almost never what you want. And so you have to add one more field here, which is base. And that says, okay, while this looks like it's coming from the JSON-LD playground, what I really want it to come from is example.org, like this. Okay, so now I've said the base for the subjects is example.org. So now I've actually generated 2 triples and emitted them, and I've got a subject, predicate, and object on the whole thing. One of the things we need to note, because it's important when it comes to our FHIR specification, is that the ID can either be the subject or it can be the object of a predicate. We don't have any way of doing both. Now, another thing you can do is, instead of saying ID is the alias for ID, I can go down here and I can just add a field. I can say, okay, the ID of this is 111111, just to make it clear that it's different here. Okay, so I've taken a slightly different tact, and instead of saying that whenever you see ID in the data record, it is actually the subject, I've put it this way. This is one of the minor tweaks I'll show you in FHIR in a little bit. The one other thing, let's see, 2 other things.
Just the one thing is, what's the difference between vocab and base?
Base covers the default base of the subjects when they occur in here, of the IDs. So if this isn't spelled out as a full URL, the base covers this. Vocab covers the default vocabulary of the predicates.
Okay.
So it comes there. Okay, now one of the things, as folks that are familiar with JSON know, is that there's only about 3 data types in JSON. There's numbers, there's strings, and there's Boolean, and there's null, which is an interesting one that we don't deal with here. But the question in XML, you've got all of these great types, like this is defaulted to integer here. But how do we tack on RDF and the XML schema data types? And the way we do that is I'm going to replace this age with this. This is an equivalent definition. When I say age sto.age, I'm saying age ID sto.age, but I can add a type field in here now. I can say, okay, the type of age is actually a positive integer. And you'll see down here, I've changed from the default of integer to positive integer. One other bit that I want to add in is, let's suppose I've got a JSON-LD or JSON, sorry, list. So I've listed a set of hobbies for Jim down here. And the default setting for hobbies is it treats it as an unordered list, despite the fact that in JSON, this is an ordered list with 2 entries, one fishing and one basset spinning. Down here, we just get 2 nodes, hobbies B node 1, hobbies B node 2. One of the things you can do is we can spell out a bunch of additional detail on hobbies in this context. Okay, so it's the same idea, but okay, the default is set, so nothing's changed now, but I can change this to list. And if I do it this way, this then translates it into the RDF list realization with the first, next, nil syntax below. And okay, now the other thing, and the reason that I put hobbies in here is you'll notice that I've got a name here that's Jim, and I've got a tag inside here that's the name of a hobby. And in JSON-LD 1.0, I was only allowed to assign one map for name, no matter where it appeared. So if I'd said it was friend of a friend name, I'm going to pull these lines out briefly to show you what goes on here.
For grammar geeks, I'd just like to say that JSON-LD 1.0 was context free, and JSON-LD 1.1 in this feature that Harold is describing here is context sensitive.
Yeah.
So if that helps you understand what he's saying.
Yeah. So there's a place on the options I can set this to 1.0, but I'm not going to futz with it at the moment. Suffice it that even if I did have this inner context in hobbies, I was going to get friend of a friend name for Jim and for both of the hobbies. And this was the showstopper when we were trying to use JSON-LD 1.0 with FHIR, because if you look at the FHIR data structures, you'll find that a person has a name and a code has a name, and common attributes like name and ID and many others have different meanings in different contexts, and we weren't able to do anything with that. JSON-LD 1.1 introduced this great new feature, which is basically you can use nested contexts. So now I can say, well, inside the context world, I want to when I'm inside hobbies, basically, I want to reassign name to, I call it ontologies or a silliness for no good reason. But I So I've got a different name. So out on the outside here, I've got friend of a friend name for Jim. And on the inside here, I've got fishing and basset spinning as a different predicate. So that's a real brief introduction to JSON. Yeah.
I have a quick question, and I think it's I think I'm a little bit confused, so I need that clarification. JSON-LD, the way I see this in there, it's converting one JSON to another JSON. What I want to know that if you have not written these mappings,
Wait,
you
so
can you can
there. I
still,
don't think that's
Well-
quite right to say that it's converting one JSON to another JSON. I
Well,
don't think that's quite the right way to think about it.
It actually, let him carry
no,
on.
I mean,
David,
let me-
because, I mean, this is what it does right here. This is actually this thing
Yeah.
called expanded. This is the target JSON. So it really does convert one JSON to another JSON, interestingly.
Yeah, it does, but I think it's a little misleading though. So, but go ahead, Sajjad. So,
yeah. So what I what I was saying, that if you take any JSON and before doing this mappings, can you show the enquads section of that? That means any JSON can be converted into n triples,
Yeah.
right?
Yes.
Without creating the mappings here.
Well, yeah. If you don't put in the
Wait, give me-
context, if you don't have the context, you can't. If you don't have what I've just put in here up above, we have no way of knowing what to do with name. The most basic context we can put in, if you want, we could put in a context that just had, let's see, I'm going to pull this out. It just has one field.
Okay.
And so on a trivial level, yes, we have converted this into RDF, but it's rarely, if ever, what you want. I think another thing to be aware of is while in this example up here, I've got this context in line. If I had a file sitting out here somewhere, and you'll see that in a bit, that had all of this inside it, I could replace all of this with I could do it this way. And if this were actually out on the site, it would fetch this context. And even more so, the JSON-LD processors, you can feed the context into the processor. So you don't actually have to edit the JSON at all. You can say, interpret this bit of JSON below according to this context. And the cool thing is that allows you to put in multiple contexts. So you can map it to one set of URLs for one purpose and another set of URLs for another purpose.
So yeah, understand. So the way I was mentioning is that is converting one JSON theoretically again, I do respect that the work, one JSON to another JSON, but also on fly converting the attribute names to those predicate names, subject, predicate, object, and also doing that subject part with base and ID and so on and so forth. So there are some syntactical conversions there too. But the way I see this is there is a JSON, and for any JSON with the context, at least the context part, you can not convert, but see this as an RDF triples.
Yeah.
What we're doing is a step ahead, is that while doing those their attribute names in JSON, we are converting into fully qualified predicate names.
Yeah. Okay. If you look down below on this expanded portion, JSON-LD naively, and I say naively because if you don't deal with all these compaction things, is simply another way of representing RDF. Just like you've got Turtle, just like you've got RDF XML, you've got N3, you have JSON-LD. And you don't need any context or anything to convert a block of RDF to an expanded form of JSON-LD. It's just the form of predicate this is the fully expanded form type object, predicate, list type object, etc. And I can take any RDF I've got, any RDF you give me, and any of the standard RDF converters will emit this. JSON-LD or the contexts are a set of rules that allow you to go to and from these tags like age to these URLs. And the cool thing is you can go both directions. I'm not going to talk about the other direction, but there's something called framing, where you can take some RDF and a JSON-LD context, and you have to supply a couple of more rules because JSON is a tree and RDF is a graph. And so if you're going to convert RDF to JSON, one of the things you need to do is say, I want to start with this subject so that you can start unraveling the graph. And the other thing you need to do is, because two elements in the graph can represent the same third element, you have to tell the framing library, do I want to replicate those? Do I want one to be a reference to the other, etc. But
Yeah.
anyway, this.
So just a final thought that again, with due respect, in my understanding, under the hood, it's a JSON to JSON transformation. I mean, representation point of view. While during that transformation, there is an on-fly attribute to predicate transformation, because any JSON will can be just realized into triples. That's my assumption is.
Well, any JSON can be represented into triples, but for useful triples, like referencing schema.org, you need the context.
For sure.
Yeah. And so, yeah, with a vocab, we could convert any FHIR JSON into RDF. It just wouldn't conform to the RDF spec for a whole lot of reasons.
Clear.
So what I want to do is have
Harold, can I interject a little bit there? So Sajjad, the reason I don't think it's good to compare JSON-LD with XSLT is because it's not intended to be sort of a general purpose translation or transformation language. That's not the intent at all. The fact that it is going from JSON, from one form of JSON to, yeah, in some sense, it's another form of JSON, is, I think, maybe a little bit misleading, because really the intent is not so much a transformation as a clarification, right? In order to, for example, disambiguate the property names from one JSON into that other JSON. And so the transformations that happen with JSON-LD, they're really very much one-to-one transformations. There's a one-to-one relationship between or almost one-to-one between what's in the JSON and what comes out in, for example, RDF triples. You cannot add more RDF triples than what was in the JSON properties, for example. So I don't think you're well served if you're trying to compare it with XSLT, because it's quite a different.
Definitely. I should.
Okay.
I'm taking this XSLT remark back. I mean, it's nothing to do with XSLT. I would just it was more of a clarification. But when it comes to
I just want to make sure you weren't being misled about it. That's all.
Yeah, definitely. I mean, XSLT is a general purpose transformation from XML to XML, and nothing else. Whereas here in JSON-LD, what's happening is that underlying, you are still served as a JSON while converting into RDF, first of all, these needs to be fully qualified predicates. So there is a context coming.
And that's
And-
really the purpose. Yeah.
Yeah,
right.
Is to fully
And
qualify. Yeah.
I sort of need to dive back into this if we're going to get through it. So what I've done is I've taken us to another site. We shamelessly stole the code out of that JSON-LD playground, and the group we're working with created a FHIR-CAD or a FHIR JSON-LD playground.
That should look just a little bit familiar.
Yeah, it should. And if you go to the JSON-LD playground, they had a bunch of pre-canned examples. We have sort of the same thing. These are just sample bits of FHIR JSON. So if you click on patient here, what you get is this is just taken from one of the examples out of, it's probably a bit dated, but nonetheless, this is just a FHIR patient resource as it exists today out there. Okay, now what we mentioned, and I'll show a bit more of it here, but what we mentioned is that it's not a simple transform. One of the places, for instance, is we've got the ID. This does become the identifier of this record. This becomes the subject of this record. And FHIR has a set of rules about how to do that. But if we convert it to the identifier of the record, it becomes the subject, and this field, which is the ID, which people count on, disappears. So one of the minor things we have to do just right off the bat is we have to replicate this. We have to add another ID field so we can get our subject without disappearing this field. Another thing we need to do is to convert this into an RDF type. And other things I'll show in a minute, the active true here. Oops, sorry about that. Okay. The active true here, we have to do it. So there's a set of structural transformations. So what this JSON-LD R4 tab is all about is this does the necessary structural transformations to the above schema so that we can actually process it. So as I mentioned, the resource type, it gets converted from just patient to FHIR patient. And the JSON-LD says that this is actually an RDF type. I'll show that in a minute. The ID, which was just pat1, just like Boolean and everything else, is extensible. So we've turned it into an inner structure. If I go down further here, same for active. So the thing that JSON-LD can't do is it can't introduce new nodes that didn't exist in the JSON structure. And similarly, it can't add new data that isn't there already. So if I go down a bit further here, right. If we come down to the relationship, which is coded up here, where is that? I need a relationship, right? FHIR has, well, they have URIs for code systems. FHIR doesn't specify the URI for concept codes. And that's just kind of like the core of RDF. So one of the things that we do in this transformation is this line right here. We've said we know how to translate this particular system and code into a URI. And so we've added a URI here. Another thing that we're doing on this one is I'd shown earlier, the two forms that JSON-LD can emit are either the Lisp-like lists that are built into RDF, the first, next, and nil, or cotter type structure that drives everybody mad to use, or an unordered list. In our spec, we decided that we didn't want to make everybody have to navigate RDF lists. There was a lot of opposition to that. But in order to conform to the FHIR spec, we actually needed to preserve the order. So we've introduced a new field here called index, which is just a relative ordering if there was more than one coding in here, the next one would be index 1, etc. So there's a lot more here, but what we've done basically is we've done the structural transformations that are necessary. This little bit of stuff here is what we need to turn this into an OWL ontology. We can emit RDF, but if you use Protege or reasoners of any sort, OWL ontology is a poor man's document name, basically. This is giving us the stuff, and I'll show it to you in a second. But the other thing here is you'll notice that we've got two contexts. I'd mentioned earlier that you can reference contexts. So I'm adding these things together. So if I go up and dereference this here, this is a server that at the moment we're maintaining on firecat.org. This is the thing that eventually we would expect FHIR itself to host, which is every context in this particular schema. So this is the context for the patient resource. You've got the vocab with the unknown I mentioned earlier. You've got the prefixes, which are a very limited set. You'll notice art resource type. I take resource type and map it to RDF type, so that becomes the type predicate, and whatever the type is over here. So if I go back to FHIR patient, that becomes the type of the patient. And the other thing you'll notice is that every field in here has its own context. So if we go down to the active field, for instance, this takes us to a context that we've defined for FHIR Boolean. So if we go up here and paste this on here, this is the JSON-LD context for FHIR Boolean. It supports extension if it's in there. It says that the internal value field is type Boolean. And here's the index I was talking about, that if we have a list of Booleans, that's how it's ordered. So these contexts are all out there, and we have the code written to generate all of these contexts. We're in the process of getting them introduced. So the next step on this playground is I've created this transformation here. We've got a little thing that says, okay, replace what was up there with this. Now that you've done the transformation, and by the way, you can paste any FHIR resource you want into this JSON-LD input, hit the JSON-LD R4, and then copy it up. I have no idea why it says system slice is not a function, but it doesn't hurt us. So now if I come down and look at the enquads, once it goes out and fetches all this, what we've got here is a set of RDF that conforms to the current specification. We haven't written, well, we have written FHIR specific code. The FHIR specific code we've written is the bit that took ID pat1 and turned it into ID value pat1, took the status active and turned it did the structural transformations. But other than that, we're running directly off of this set of contexts here.
Harold,
So,
that transformation that you were just referring to, where is that running? Like when you hit the JSON-LD R4 tab, is that just JavaScript that is doing those mapping steps?
Yeah, that's the JavaScript for this. And I know somebody was going to ask, and I need to go out and find the GitHub repositories that have these things in it. One of our tasks for the AIM1 is to get some of this cleaned up a little more. We have a very good Java library that does this transformation. This JavaScript library is the one we're running here, and that's out on GitHub. And we have a Python library out there too that needs a little bit of cleanup, but we'll do the same thing. We'll do the structural transformation for us. And so the good thing about here is that if we change the FHIR specification, and that's one of the things we want to be able to do, is to fix some of the in our first version, some of the things that we didn't get 100% right. We no longer have to go to the happy people and say, you need to change your code because we've decided to go here. The majority of the changes can simply be introduced into these contexts. If we publish a different context that has different maps, different things come out. You will notice also, FHIR R4 is context generated from the R4 build. The original part of this directory is because we've got, I don't remember what we put in, but we've got another directory out there where we've just been kicking the tires on some of the change proposals for R5. But the nice thing about that is that we can, the majority of the changes can just be reflected in a context, pointed at a changed context, and you get changed output. Let's see, what else? I think that's probably as far as we can get. So the take-home message is, as long as there's a JSON-LD 1.1 processor, and they're taking a little longer than what we'd hope, but fortunately, thanks to Kevin Peterson amongst others, we have a great Java JSON-LD 1.1 processor and a great JavaScript processor. Python is necessarily going to come into existence because we're using it in other contexts. So that leaves us with the C# out there that we're going to have to chase. The other thing we're hoping to do for the R5 transformation is to minimize some of these structural changes. In particular, we made kind of a classic design error that you get, which is, I mean, the rule of thumb when you're doing modeling is make the normal easy, make the possible possible. And we sort of made the possible easy and made the normal really confusing, in that nobody's ever, well, I shouldn't say nobody, but the odds of somebody extending a Boolean are diminishingly small, and we need to be able to handle it. But what we need to be able to do is just have plain old active true here. What we're is true. We want it to look like that, which is what it was in the native JSON. And we're trying to reduce the number of transformations we've got here to an absolute minimum. We can't do much with this index thing, but we're hoping to push this back into the JSON-LD community. The problem of ordered lists that aren't Lisp lists keeps getting kicked around in the W3C, and you know, you pass it to JSON-LD and they say this is a general problem, and Eric can tell you about some of the things we hit on this. Real briefly, and then I'm done, is you'll notice down at the end here, we have the ID of the resource itself, and this little included thing here is what puts the OWL header on there, build FHIR org. Let me just take you to a sample so you can see it, and then I'm done. So I'm going to just go to, let's see, I'll go to the allergy resource, go to an example, pick up the example. Eric very wisely had us put this at the end because we figured it would reduce the number of questions. But this is the ontology editor we were talking about right here. This is the bit that allows you to import this into OWL and use it sensibly. And we have to bolt that onto all the resources. So that's it.
This was
Awesome,
really
Harold.
helpful, Harold. I feel like I have 10 million more questions to ask you about this, but we can have that discussion in a future meeting.
And be aware that anybody that wants to can twiddle away on either the FHIR or the JSON-LD playground. And if you want to pass somebody a link, you can say create a permanent link, this wonderful tiny URL where they're starting to get really crabby. I can copy that, and then I can paste that into the chat, for instance. And that URL gives you exactly what I was looking at. So that's another thing.
Bear in mind that only works up to up to the length that a browser will swallow a long URL. So
Yeah.
if you paste in an enormous thing, you won't be able to tiny URL it effectively.
Yeah, it's fascinating because the URL contains all of the data. So this was the long URL. This actually has everything that's on that screen. Yep, happy to answer questions. And I realize this is kind of like a from the fire hose, but I think these jump off points between the basic playground and here, I never can remember where we've stashed the contexts, but by going, I always go here, put a paging in, convert it to R4, and then that gives me the URL of the context we're using today.
So thank you, Harold. This is great. I'd like to get some feedback from people about what they would like to see next. What would be most helpful in terms of next week's call as follow-up to this?
Well, one thing that would be helpful for me is to understand a little, but we don't have to do that in this call if there's a better venue for it, but to understand how the FHIR transformation is happening now, to understand what we would be replacing with this new, better, improved process, because I just don't have visibility to that.
Right.
Well,
Okay.
so one thing that would be worthwhile, David, I think would be to pull up the happy server that actually handles FHIR RDF and just like submit a sample patient maybe and fetch some data using RDF just to show how it works in that context.
Okay.
A cute demo of that would be posting turtle and getting back JSON and then and then patching it as XML.
Yep. Well, patching or putting, I mean, works, post put, yeah, the various options there. And then just fetching it. So now that it's out there on Happy, or at least that's what I'm told, that would be extremely useful.
And what other thoughts do people have, or what would be, what do others think would be helpful for good to go over next week? Any other thoughts? Okay, well, we're out of time. Thank you very much, Harold. And I'm glad that we recorded this too. I'll try to get this out onto YouTube so that people can watch it again if they would like, or others can watch it if they missed it. So I guess that's it for today. Any final comments, everybody?
Thank you.
Yeah,
All
thanks,
right, I
David.
guess we're adjourned then. Thank you all. Okay, bye.
Cheers all.
And I guess I'll just stay on for our next call that is on the same channel.
Same bad time, yeah, same bad channel. Yeah, actually, I was wondering, everybody was like Harold and Harold doesn't stick around for those.
Well, he may have forgotten that it's the same channel.
What's the next one?
It's a project call. It's not
Yeah,
a standards call.
Yeah.
Yeah,
Hey,
just
Rob,
happens
how
to
you
be
doing?
using the-
Good. Hi.
Good to hear your voice. Been a while.
Yeah, good to
Yeah,
hear
glad you could make
all
it.
these voices. It's been a while.
Yeah, we're getting
Yeah.
the gang back together. You're getting the band back together, as Harold kept saying.
Yeah.
I was doing some multitasking today, but it was pretty interesting. I was trying to listen as close as I could.
He was going through a lot, so
Yeah.
I'm impressed if you were able to follow, because a lot.
Well, not
lot in it.
totally, but I mean, as much
Yeah.
as got the gist of it, the basic gist, I think.
Good. Good.
Are we confident that we're on the right channel?
Well, I guess I should verify, but and also I realized I need to stop the recording too.
Oh yeah.
Stop the recording. Yes.